In section 7.6, we are really going to be doing a lot of the same things that we did in 7.5 with solving exponential and logarithmic equations, but now we are working with natural logarithms. If you remember back in section 2, we learned about that number e. And we talked about it's about 2.718, and it keeps going. It's an irrational number. Let's also flash back to some of the other things we know. We know y equals 10 to the x. Its inverse is y equals the log of x. And remember, when our base isn't written, our base is really 10. It's common log. So our exponential functions and logarithmic functions are inverses. So let's think for a second. What would be the inverse of y equals e to the x power? Remember, e is a number, so we can do this. Well, its inverse would be y equals the log base e of x. And e is a pretty important number in the math world. We've seen some uses for it with continuous growth or continuously compounded interest. We'll keep seeing more especially as we work through this section. So e is actually so important, in fact, that this log base e has a special name called the natural log, which is abbreviated ln of x. So whenever you see natural log ln, that means it's a logarithm, the base is e. Really, a lot of the things that we've done before, that we did in section 5 and even before, work the same way with natural logs as they did with our common logs and logarithms with other bases. For example, our log properties, and that's what we're going to see in example 1 here. I'll do 2 examples here. Feel free to try the second one on your own, or really your first one too if you wanted to, but feel free to try these. So first one we're going to write is a single logarithm. Let's do the natural log of 7 plus 2 times the natural log of 5. And also write the second problem down here too, just in case you wanted to try these on your own, since they really are what we know already. 3 times the natural log of x plus 2 times the natural log of 2x. Okay, let's start here. In order to write these as a single logarithm, I first need to get rid of our coefficient here. And this coefficient can move to our power. So this is really the natural log of 5 squared, the natural log of 25. And now if I have a natural log of 7 plus the natural log of 25, a log plus a log, I can multiply the two pieces together. Natural log of 7 times 25 is 175. And that is your final answer. Now over here are 3 times the natural log of x plus 2 times the natural log of 2x. Same idea. In order to do anything, I need to get rid of my coefficients. So this 3 can move to a power. It's the natural log of x cubed. Really, this part's the trickiest. I have the natural log of 2x. This 2 becomes an exponent. 2x, quantity all squared. That really makes 4x squared here. And then to combine these, natural log plus another natural log, multiply the two pieces. That gives me 4x to the 5th. Natural log of 4x to the 5th would be my final answer there.